Joseph's daily commute is from home to school to work, and his route estimates this pattern here. If we like make a solid line through here, of course, this is a triangle that we have, and it's an isosceles triangle since we have two sides of the same length. And Joseph's total travel distance is called the perimeter, right? He'd be going this way, and then this way, and then this way here. And that distance is the perimeter, called the perimeter of this triangle. It's just the outside travel distance. What's that travel distance? It's just going to be 3 miles plus 6 miles plus another 6 miles. 3 plus 6 is 9, plus 6 is 15 miles. Perimeter of any closed shape is really just the sum of the side lengths. Now, the perimeter can only be found on closed shapes. As you can see here, a closed shape is one that is has all the sides meeting at vertices. There's no open sides, as you can see here. There is an inside and an outside for a closed shape. For an open shape, there is no inside or outside because you can just pass right through it. So perimeter only really makes sense in closed shapes here. So this is a closed shape, and what's the perimeter of this shape? All we have to do is add up the side lengths. So we have 6, 7, 4, 4, 5, 6, and 2. So adding these numbers up, we're going to get 34. Now, a polygon is a closed two-dimensional shape. So a two-dimensional shape is going to be having length and width. It's going to fit on a plane, which is just a flat surface. And a polygon has a specific number of sides that we talk about. A triangle is the only three-sided polygon, or also called a threegon, since it's got three sides and it's a polygon, threegon. That's just a simpler way of saying it. Now, for four-sided shapes or four-sided polygons, we have this kind of labeling structure that we can follow. A general four-sided polygon or fourgon is called a quadrilateral, quad meaning four. And then we can get a little bit more specific. If we take two of these sides here and we make them parallel, so this side is parallel and this side is parallel, meaning they go the same direction, then we have a trapezoid. Now, some texts will say that a trapezoid can, all parallelograms are trapezoids. Some of them make a distinction between the two of them here. It doesn't really matter. What's important to note, though, is that if we have these two sides also being parallel, then we have a parallelogram. So this side and this side are parallel, this side and this side are parallel. So that's what makes a parallelogram. Opposite sides are parallel, and because they have to be parallel, they have to also be equal in length. So this side and this side are equal in length. This side here and this side here are equal in length. If we kind of align the parallelogram to be straightened instead of being slanted, then we're going to get a rectangle. And that means that all of these angles are right angles. We still have opposite sides being equal in length. So this side's equal to this side, and this side up here is equal to this bottom side there. Instead, if we make all the sides equal in length, then we have a rhombus. A rhombus means that these sides are parallel, and all sides are equal in length. That's what's shown here with this mark. So every single one of these sides are equal in length. These angles, however, are not right angles. That's the important difference here. A parallelogram, if we get right angles in there, that's what makes a rectangle. If we do not have right angles there, but we have equal sides, that's what gives us a rhombus. If, however, we combine these two classifications and then into one, we have the square, which is all angles are right angles, and all sides are equal to each other. So the square is the most rigorous definition of a quadrilateral. And then you can see that all squares are rectangles. All squares are also rhombuses. Like you can always use that classification. A square is a parallelogram, just like rectangles and rhombuses are parallelograms. And then with this kind of setup that I have shown here, you could say that all parallelograms are trapezoids. That's not necessarily the case for everyone thinking that, but all of these things are all going to be quadrilaterals because they're all four-sided shapes. Now, a convex polygon is where all interior angles are less than 180 degrees. So interior angles being these angles here. All these angles are less than a straight angle, right? A straight angle being 180 degrees is completely straight across. And all of these angles here are less than that straight angle here. So this is a convex polygon. It's a four-sided shape. These two sides are the same length. These two sides are the same length. This is called a kite. Now, the only type of four-sided polygon that can be concave is something that looks like this. It can, of course, be adjusted a little bit where it has one side being longer than the other side, something like that. But it's going to be somehow resembling this. And this one has a single angle that's greater than 180 degrees. And we're talking about interior angles here. This is called a concave polygon, a concave quadrilateral specifically, since it has four sides. And this of course, just looks like an arrowhead. I don't think there's any specific name for this shape. Okay, we can just find perimeters of specified polygons by using the definition or the name of it to help us with the actual mathematics. So a square with side length 4.2 centimeters. A square has all sides equal. So this is 4.2. That means this is 4.2, this is 4.2, and this is also 4.2. Because that's what a square means. The word square means that all sides have to be equal in length. And the perimeter then is just going to be 4.2 plus 4.2 plus 4.2 plus 4.2. Which of course is the same thing as 4 times 4.2. That's going to give us 16.8. And this is in centimeters, so that is the perimeter of this square. A trapezoid that has these side lengths here, all we have to do to find the perimeter is, you can see that this is a trapezoid because we have these two sides are parallel. And this side are not equal in length. So this is definitely a trapezoid. The perimeter for this is going to be add up the side lengths. So we're going to do 2 3/4 plus 4 plus 3 plus 2 2/3. I need to have common denominators here. So I'm going to multiply this one by 3/3, this one by 4/4. Going to give me 2 9/12 plus 4 plus 3 plus 2 8/12. So in total, we're going to have 2 plus 4 plus 3 plus 2. That's going to be 6, 9, 11. And then 9 and 8, 9/12 and 8/12 is going to be a total of 17/12. Of course, 17/12, right? 17/12 is the same thing as 1 and 5/12. So 11 and 17/12 is the same thing as 11 plus 1 and 5/12. Or in total, 12 and 5/12. And this is going to be in feet. So that is the perimeter of this shape. Okay, a parallelogram has opposite sides equal. You can also see that the opposite sides are also parallel. They're going the same direction. So opposite sides equal, meaning that this side here is 31.441. This side here is also going to be 31.441. This side here is 87.346. So this side is also 87.346. And so to find the perimeter of this shape, we just need to add them all up. Now, instead of going, 31.441, 87.346, 31.441, I can just do this. I can do 31.441 times 2 plus 87.346 times 2. And that will give me my desired shape. So putting that in a calculator, I'm getting a perimeter of 237.574. And there is no unit given, so this is the best I can do for that. No unit is given here, so this is my solution. Okay, a rectangle with length 310 and width 140. A rectangle has opposite sides equal in length and all angles 90 degrees. So the length is going to be the long side is 310, and that's going to be feet. And the width is the shorter side, 140 in feet. The drawing's not to scale, I'm sure, but that doesn't really matter. The perimeter around this is going to be added to the side lengths. Of course, this is also 140, and this is also 310. So very similar to the parallelogram, all we have to do is go 140 times 2 plus 310 times 2. Adding that up, I get 900 for the perimeter, and it's going to be 900 feet